All right, we have started recording. And as we move along, if there are questions, please do voice it. I may not be actively checking the chats, or if Bhavesh, if you could keep an eye out on the chat, and if you see some question pop up, I'd love to get some help on heads up with the question.
Sure, will do.
Yeah, thanks. All right. Why is that not going away? Okay. Oops. So yeah, what is Kubernetes? This is directly from the Kubernetes website. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. So all three aspects of it, where you are not only deploying with a fully automated capability to deploy, which Kubernetes provides, but the scaling and the management of it once that's deployed really are the crucial aspects of what this platform provides. But the most important element here is the containerized applications. Kubernetes is an orchestrator when an application is already containerized. Which brings us to what is containerization, which is not at all intended to be the in-depth scope for today. The assumption is people know applications can be containerized, and one of the mechanisms for containerization of application is by using Docker. Docker is a platform. Again, the most popular, not the only way of containerizing, but most popular one. And Kubernetes supports other mechanisms as well, but Docker again is the most popular one. So that's a platform. Docker is a platform that allows the containerizations. So all you do as a developer is write the application source code and then specify how to build it. And that specification is done using a Docker file, which we will definitely look at peripherally today, since it is such an important aspect of leveraging Kubernetes as an orchestrator. Can someone mute, please? Thank you. So that's the definition. Why Kubernetes is really sort of my favorite part about it. You know, my own background. Some of you may have met me before. If not, I was saving the introduction to why Kubernetes simply because all the way from auto scaling to horizontal scaling, reliability, lack of all of that has been my entire career. I have been on the engineering side for really large scale applications with millions of users going through the system, and being part of platforms teams that had to ensure both the scale and the reliability, starting with monolithic code bases, where some of you may be already doing this or have done it. You know how tightly coupled the systems can get, and you are really reliant on very, very heavy load from a systems point of view in order to scale and have high availability for large scale systems that are monolithic. So many of the problems that Kubernetes solves is coming from the issues that monolithic code bases that are tightly coupled at scale were facing maybe over the course of particularly the web and the internet world in the last 20 years or so. One of the biggest issues throughout that process. Can people please mute themselves?
Oh yeah, Raman. Oh my God, yes. Let's get Jinya.
Guys, may I please request you to mute?
What is karate?
Aditya and Abhilash, can you please mute and you can unmute yourself
Oh.
when you are going to speak?
Okay, so.
Vidya, you can make me co-host, so I will try to unmute them if it is possible.
Sure, sure. I think
Just
I'm not able to mute
going,
them right now.
coming,
yeah, I should
exchanging, also other shopping, all of that. Maybe an hour and a half.
Mute all. Okay.
Yeah, mute all.
Thanks. Oops. What was that? Okay. So, and so the why aspect there is kind of been, I would say, my entire career being on the engineering side, helping large scale systems, both from a deployment perspective as well as providing platforms and internal libraries that allow for monitoring and alerting and of course starting with logging, all of the services that need to be part of a large scale operations. So those kind of platform capabilities were always super difficult in a monolithic code base that always gets deployed onto bare metal. In most of, again, my original experience before all of the newer technologies came about, these problems were day to day what my teams were solving for, and writing software that would help the scalability or help with the deployment to multiple environments, helping with certain elements of self-healing, very, very much still scratching the surface because of, again, how tightly coupled the systems tend to be. And then when it came to scaling, it became even more difficult when the need was just certain features to be made available at scale, but the only solution was to actually spin up the entire application and not really leverage the power of microservices, which you do have now, and say that you're scaling only certain services instead of the entire application. So with the movement from the monolith to microservices and then containerization, some of which we covered, if again, those of you who remember from last session I did, was really that journey that kind of led the container orchestrator like Kubernetes to come into play. These problems that the orchestrator is solving is what was originally being solved within Google using with their Borg platform, and then that was subsequently open sourced, and now it's maintained by the CNCF, which is the Cloud Native Foundation, Cloud Native Computing Foundation, CNCF, and one of the largest supported open source project for sure. These capabilities provided by Kubernetes is what makes the system highly desirable for developers to both learn as well as start figuring out how to get your own development skills in a cloud native fashion. So some key concepts that we will only touch on some of this for today, but some key concepts that we definitely will touch on will include Dockerfile and the image build, clusters and Kubernetes configurations, Kubernetes pods and deployments. The first four mainly. We'll briefly touch on the others. I don't believe we will have time to go in depth in many of these areas, but we'll definitely touch on that. This one I am planning, what we have right now is a part one. I do have a part two planned out already for stateful applications with databases. So stateful sets is something that's provided as part of Kubernetes, but definitely don't intend to cover it today. Dockerfile and an image build is where we're going to get started. Any questions so far? Okay, I will keep going. Image build and Dockerfile is at the core of what I was talking about earlier from a containerized application point of view using Docker. You basically build your application into a Docker image and push that application. That's really how simplified it gets. And you do that by writing a Docker file for your application. So here is a sample Docker file that you would always see. There will be a base image that the Docker file would be based off of. So for example, a base image might be like from a certain version of Node. There would be a directory that for copy run commands, you would specify that. You would also specify the install commands. If in this case, it's a run npm install for the from the package .json files. So the Docker file will really have all the commands that you would. Of course, you could totally be running this individually as well, but the Docker file will act as one unit that will also tell you, tell the system where you want the container to be accessed through, which port are you exposing, as well as how to run the microservice, let's say, that's associated with that image. All of the details will be called out in the Docker file, and it will have commands like the example shown here. And later on, we'll just quickly look at a sample that we will use for the hands-on exercise as well. Just curious to hear from the audience, have people used Docker files? Are most of you currently using containerized applications? Anyone who has, let me ask it this way, anyone in the audience who has used Docker files and have already containerized their applications? Any?
Yeah, I did actually.
So can I ask what's your system?
Basically, we create Docker containers and we use Amazon's AWS Elastic Cloud Container Service, which is like similar
Yep.
to the Kubernetes.
Yep.
So we host it using their own in-house container hosting system.
Got it. Got it. Yeah. So do you use ECS or do you use the what's the or do you use something like Fargate?
So within ECS, there are like we can have our own instance and the Fargate. We use both actually.
Got it. Okay. Anyone else? Very limited exposure to Docker files and Docker machines. Okay. That's cool. Yeah. So for this hands-on exercise today, we are using the container image for a very simple hello world using it's a Node.js hello world. Here is this a sample snippet. You will get a link very shortly. Oh, let me ask this: are people in a situation to actually play with this and follow along? Couple of commands, not too many. That is the plan. Those who aren't definitely can listen in, but those of you who can, please do have your browser ready. That's all you will need, nothing else. And here is the sample Docker file that is being used. So similar to what you saw in our earlier slide, right? This slide had the sample showing it'll have where is the base image from and what is being exposed, so on. This simple Docker file has the base image from this version of Node, and then it's exposing port 8080 and then copying this server.js and that's the command to run. So this Docker file is specifying all of those commands in a format that'll then make it easy for the Docker core engine to interpret and run the application. So that's kind of an overview of Docker and Docker file for those of you who are not familiar on that side. I want to now jump into Kubernetes configuration. So again, Kubernetes is providing an orchestration. Now imagine if you have, of course, we are still going to use a super simple hello world today, but and a hello world application can run with some Docker files providing an image and then containers being spun off based out of that image. Even for a website that you might be running with hundreds of users, you don't really need any orchestration per se. You could totally be running that off of directly the Docker images. But imagine if you need to scale up that traffic to thousands of users, if not hundreds of thousands of users or more, then the scale that you need to operate at would now suddenly require that all of the images that are getting spun up with these containers need to be kept track of, and wherever it is that you deploy, we will get to the deployment configurations in a second, you need to track all of that availability. And sometimes containers may or may not stay up and running, and that needs to be tracked. And then all of the scaling needs that we will need for the entire experience of the user. All of that capabilities now suddenly become a huge overhead for you to carry on just through Docker or the direct use of any type of container. That is where the role of an orchestrator comes in order to make the scale possible for all of these containers. And the orchestrator itself could be providing multiple configurations under which it can function. And in this case, Kubernetes is no different. Kubernetes can function in a very simplistic view, which is again, the sample we look at today, is that everything is in a single node installation. So the master, Kubernetes follows a master slave setup. There is a master with worker nodes, and all of that is going to can be installed as one unit, if you will, using something called Minikube, which is what is going to be leveraged today. Single node, single master and multi-worker installation, single node, multi-master, multi-worker installation, and multi-node, multi-master, multi-worker. All of these are possible, and when you do have something at scale, you will minimally, especially from the availability perspective, you will definitely be configuring at least single node, multi-master, multi-worker, so that you are able to have a production setup that is highly available. For the sake of today's exercise, we definitely don't need any of that. And we can get, like I said, we can have subsequent sessions if there is interest with those flavors of installations as well. But for today, we are going to say all in one single node installation. Is that making sense? And we are going to use something called Minikube. So what we need to know about Minikube is that it is installed and runs directly. Again, if needed, you could be running this locally. You could be installing Minikube locally directly on your Mac or Windows. It requires some basic setup, including some hypervisor that should be installed, and it builds all of its infrastructure as long as that installations are available. Again, to simplify today's experience, especially from a setup point of view, I did not want to have the very first hands-on session with all these setup given how many people had responded saying this is very, very new to them, Kubernetes as a concept. So we're going to start very simple by leveraging some pre-existing Minikube setup that's provided directly on the kubernetes.io website. But this is important to be aware of. Even if you want to replicate using what we try today in your own laptop, you can install Minikube and try that. The other aspect that we will be using, all of the commands today will be kubectl. That is the fundamental way in which to communicate with Kubernetes. It's the binary used to access and manage a Kubernetes cluster. We are not setting up the cluster today, but we will be interacting with an already set up cluster using kubectl. Again, locally, you can install this separately from Minikube and definitely play with that as well. Just a note, when you do install kubectl after the Minikube installation, you may see some warnings, just something to keep in mind. if you're doing this by yourself after the session today. And before we jump in and also play with the concepts that you may want to be aware of, includes the notion of a pod. So a Kubernetes pod it's the fundamental unit of how a Kubernetes cluster exposes the containers that are being set up within the cluster. So a pod can be one or many. So it's basically a group of containers that can be tied together. From a developer perspective, really, what you need to know about a pod is that it can have one or more containers. From an administration perspective and networking perspective is where the concept of a pod is very powerful. Because it's allowing you to group all of these together and administer and network it together from an optimization point of view at times, because you don't want, if it is possible for multiple microservices to share some of this, you could totally have it in the same pod and not necessarily split it. You can specify as a developer just one container per pod. So it can be one-to-one, or it could be that in one pod there are many containers. The deployment file is where you will specify all of that, and we'll look at that also, some samples of it later today. But from a network and administration perspective, this also gets quite interesting when we do part 2 or part 3 sessions about administration. We can get into those aspects. But from a developer point of view, really what you need to be aware of now is you can have multiple containers in the same pod. Another important concept of Kubernetes that really allows the power of this orchestration is through the notion of deployment. So Kubernetes provides this construct called deployment, which corresponds to a set of identical pods that will be created from it. So you will just be able to say create deployment as a command, and that will take all of the required information provided through your Docker files, and Kubernetes is going to then take care of setting up that deployment for you using the environment variables from the files specified. This notion of just create deployment, because that's being provided, it just completely abstracts, again, for you as a developer, that entire process of, okay, now how does all of your containers get deployed? How is that getting managed? It's all entirely abstracted for you as a developer. And that's a pretty powerful concept, especially as you get into cloud native computing. You don't have to be worrying as a developer anything beyond deployment as just a command. With that, let's launch this terminal really quick. I can put this link in the chat window for those of you who want to try this. So you will be on the kubernetes.io website. They have some awesome tutorials, and everything provided here is absolutely available for you. Just I've just kind of made it into capsules from this documentation. Can I get, are people able to launch the terminal?
We are getting confirmation in chat. Yes.
Sorry, what was that? Okay.
I'm saying that we are getting confirmation in chat. Yes.
Okay, great. So yeah, so you want to launch the terminal from here. When you launch the terminal, you will start. So basically what this is doing is launching the Minikube version for you. So we'll just wait for that to be launched. Okay. So now Minikube is running Kubernetes. Again, from your perspective, you don't have to think about anything other than now Kubernetes is started, and we are just going to go ahead and I'll continue putting the commands for you, but you're basically now going to create the deployment. From a very simplistic, this is a very simplistic sample to get us started with. So this deployment is not even relying on anything where a deployment YAML is being set up. We will look at a deployment YAML example later. The very first example here is just using the create deployment construct that Kubernetes provides. So if you see, the command here is kubectl create deployment for the Node.js hello world that we had created. And I'll put this in the chat window for you. So if you want to just run that. And if you did not already, when you launch the terminal, if you didn't notice, I just want to bring it to your attention that this Minikube that it is running, that has already started Minikube for you. In most cases, it does. It has happened to me once or twice that it did not start Minikube when I launched. So you want to just do Minikube start if for some reason it doesn't get started for you. So what we just did was the create deployment command and directly giving in the giving in the parameter right here, which will normally this image. So because this is a really simple sample we are doing of a hello world, and the image is already available. So if you see this gcr.io, just means it's already available as an existing image for it to grab. Again, for subsequent tutorials, if people are interested, we can do more complex. You can even bring your own Docker files, and we could do tutorials with those as well. I need to run the dashboard command as well. Not necessarily. You can, I think someone's asking, you can run the dashboard command just to see what it is. I wasn't planning on getting too much into the dashboard right now, since that's not directly providing the details. What we just now did was created the deployment. Having created the deployment, we can now look at what was that deployment. So if you just do kubectl get deployment, that will show you. So this was done about 3 minutes ago. That shows the name and whether it is available or not. If you remember, the basic construct is that of pods in Kubernetes. So if you now look at the pods that were created as part of this deployment, it shows there is 1 out of 1 pod running. That's all that was set up as part of this sample. And that's ready and available. Now, comes another important construct within the Kubernetes architecture is the mapping of the service, which is your microservice, to how that is exposed through Kubernetes. That is done using a construct called service. So within Kubernetes, and we'll look at this a little bit in depth also later, similar to other capabilities being provided by Kubernetes, and an important one that Kubernetes does is allows you to provide that mapping between what the microservices and the services that get exposed through Kubernetes are. In this case, again, it's a fairly simple one. So the command is expose deployment. It's directly from that page. I can put it on the chat as well. So there is a question from Prakash. Is Minikube tool needed in the real production deployments? The answer is actually not just Minikube. You will, in real production deployments, you will need a lot more than that. You will probably not be using Minikube in production. I know this is kind of, it doesn't give you a good flavor when I say that, but there is so much in Kubernetes to kind of learn the concepts that Minikube is only providing you, if you set up everything in one node, so that you really can learn all the capabilities of Kubernetes. That's what Minikube does. When you are setting it up in production, you will probably do a lot more than that. Oh, wait. Looks like I just sent this privately. Sorry. Did everyone see my previous? I think someone just pinged me privately, so I replied to them privately by mistake. Here is the command that exposes the service, the kubectl expose deployment command that I just pasted. So that's going to allow you to create the deployment. And when you do that, that's getting exposed as the service. So now let's look at that service. If you do, oops, don't need an S. So what you see here is the service that was just now set up. You don't need the S. You will see the port number that it is getting exposed as minus 31935. Yours is going to be something else. So what we are basically doing here is skipping the entire setup of anything locally, so that people who, no matter what your situation is, all you need is a browser to initially get started and get to know some of the basics of Kubernetes, and you can keep following along a lot of the documentation directly here, or look at the services that we just added on. Do you need to enable other add-ons? You can, but not necessarily. We don't need, we are not planning to cover that in the session today. What we are planning is to definitely look at directly what this hello world that got exposed, what does that look like? So if you were to preview the port, here is the port number that I have, 31935. This is so annoying. I'm gonna hide that. So I'm trying to display the port. Let's see if that wants to. So if you go back and look here, this 31935, I'm trying to that should have been already deployed. See, that's the hello world that we just now deployed. Are each of you able to see your own hello world deployed? Can I get a quick response on that? So is this making sense? In terms of what we just now did was a super simple deployment, but now on the browser, you are seeing, oh, stop sharing. On the browser, what you're seeing is the deployment that was just now created. The Minikube installation is available on this platform called Katacoda that's directly allowing you, so you don't have to give any credit card, anything like that yet, because if you want to otherwise start playing with this and pushing it out to a cloud of your choice. Initially, I was planning to have everybody do GCP, and then I realized you would each have to give your own credit card, which may or may not be something you would want to do as a very first sort of even exposure to what this is. I'm glad there is a possible way to get basic exposure to what Kubernetes provides without any credit card or any such need. Now, this, after the deployment has been done, if you want to go see what the pod is and what the service is, you actually can go back to looking at that. So that shows everything that's running as part of this Kubernetes pods. You can directly grab it from that as well, or here you go. So all of the Kubernetes constructs here, all the way from an ECT, etcd, API server, controller, a manager, these are all the administrative aspects of what Kubernetes provides. And again, for you as a developer, the very first thing you are leveraging Kubernetes for is deploying your application as a container onto a Kubernetes cluster. So you really, what you really need is a cluster already set up, which is what this tutorial is already providing, is the cluster is set up for you when you're launching the terminal. Srikant, I think you are asking some questions privately. What's the URL you need to? Yeah, so I don't know if everybody had a chance to see the hello world. I want to show that again. Before, in order to be able to see the hello world deployed, the first thing you need to do, let me reiterate, is you need to ensure that you have deployed. So you need to first create your deployment. If you haven't done that, please create your deployment. After you create your deployment, you can see the deployment. You can look at it just by doing kubectl get deployment. Then you need to expose what you just now created as a service. That is how it becomes externally visible. That is the functionality again, that the notion of a service that Kubernetes provides for you. So if you do kubectl expose deployment, and that has the type load balancer set up for you, so that's doing the external exposure. Once that's exposed, you do kubectl get service. Once you do that, you will see what's the port number that your service is exposed on. So in my case, it's 8080-31935. Yours might be different. Once you have that number, you want to view, oops, you're not viewing that, wrong link. You want to click the web preview. That's what it's allowing. It is, and once you have the web preview, you want to choose view on host 1. Now here you provide whatever is your port you want to display it on, not display it on, where it has been exposed. You should be able to see it there. Is everyone with me so far? Any questions? I do want to pause here. We have taken the full hour for this. I want to pause, take questions before moving forward. The next set is actually, I would say, far more in-depth level of Kubernetes usage with the deployment YAML. We can move on to that if people are ready. But if there are questions, I want to pause and take now before moving on. No questions? Is everyone able to get the deployed application to show up? Yeah, I see many of you are saying, yep, that's good. Is this giving you an idea as to what Kubernetes is doing for you? No questions? Okay. I'm willing to bet that there is at least one question. How about I say you get a free one-on-one with with me if anybody can ask one question. I can't believe there is absolutely none. Okay, so that's awesome. Looks like everyone's following on and ready to move on. Oh, any questions? Did I just hear? Oh, maybe I need to unmute.
No, I think whoever is tried, I think they are able to follow up, so we can move ahead.
Okay. All right. Okay. Awesome. So this is the very first exposure to what Kubernetes is providing at a basic deployment level. Having done that, I want to make sure that especially the developers who are planning to use this or who are already using Dockerfile and Kubernetes are seeing some key takeaways. Whenever there is a Dockerfile and image build, make sure that the most current Dockerfile you created is being used. That's a fairly common thing where the current Dockerfile may not make it to your GitHub, and that can cause issues. That makes it harder. At this point is also when, so imagine the Minikube cluster, all of that in a typical organization. Some of you who are already facing this on a daily basis, I'd love to have you chime in as well. The DevOps team is the one setting up. Imagine the cluster's been set up for you. you have all of the pipeline after that made available to you for such a deployment to happen. That's kind of the key takeaway. So the Docker file and image the Docker file is really your responsibility as a developer. You also want to be aware of the port that you're exposing. That may already be taken. Another very, very common thing that comes up. And then in terms of the cluster, you want to be aware of the VM specifications, whether it is enough for the service you're creating. Again, this you can easily run into this if you are playing with a test instance of an AWS or a test instance of a GCP. You would have to adjust the specification of that your application may need. If everyone's okay with what we've covered so far, I want to jump into the next set of details around the deployment YAML for developers. So in today's example, we actually did not use the deployment YAML. It was super simple so far. I want to walk through some of these scenarios and then do a demo with a deployment YAML. I'll probably even have someone from our DevOps work that we do come in and do some a demo there as well. So deployment YAML, the key takeaway from a deployment YAML perspective is that it'll be the DevOps team's responsibility to specify in the deployment YAML the image, the release number of your application, or depending on the size of your team, this may not be another team altogether, but at least be actively aware of how that that process works. You also want to make sure that the Docker file is checked in properly, and that the DevOps scripts are using your current Docker file. So this again is another common, depending on how that process is set up. If it is not in the Git repo, you want to be aware of that and really partner with folks on the other side of the deployment. The image will, as an example, there will be images like this. In this case, this is a Redis image, and that will have its own image pull policy and a name that is called out. In addition, the deployment YAML, you want to be making sure as a developer that you understand the environment variables that are needed. So for example, what kind of configuration is needed? How do you manage the secrets to access, this could be to access certain files or to access certain aspects of your application. There might be some secret management, which again, Kubernetes does a really nice job of providing it. You want to be aware of that and incorporating that in your deployment YAML. Also, the example from an environment variable perspective is from a config map. Let's say DB config is already in Kubernetes. That will all be set through key value pairs. So for example, if you look at a sample here, this has the proxy and the environment from and the config map key value pair called out. Yet another example from a deployment YAML perspective could be how the proxy secrets need to be called out. That again, with the key value pairs. These are common use cases. Are there folks on the call who have examples from your own workplace in terms of how you handle this from a secret management perspective? Do you do this in a similar way? I think someone had said they do it in their workplace. I forget the name. Anyone able to chime in? And if people do have questions, feel free to ask everyone. I do have some questions coming in privately, and by mistake, I am responding privately. Can two services be created within a single cluster? Yeah, two services can be created within a single cluster. That was a recent question. Other questions, continue chiming in there. The other aspect that the deployment YAML provides, oops, sorry, I'm not in the presentation mode, okay, is the volume mount. So a typical use for a volume mount would be something like an SSL certificate. And that can be mounted, and you will be able to specify that within your deployment YAML. And when we do the demo here shortly, you'll be able to see an example of some of this as well. This is one of my favorite features, is that liveness probe that you can leverage. So Kubernetes allows you to leverage the functionality so that as an app owner, you can be aware of the health of your application. You would be able to use something like this liveness probe and say a delay of 5 seconds or even lesser than that, to constantly check in to ensure that your application is alive and healthy. And you could even add other liveness checks, health checks on top of that. The health check capability then nicely ties into other functionality that's provided by Kubernetes and other CNCF products that can sit on top of that, which we won't have time to get into all of that today, but this definitely is one of the ways in which Kubernetes provides the health check capability possible. Outside of the YAML file, another important thing at a pod level, again, for you to be aware of as a developer, is that tightly coupled microservices in one pod. So there could be multiple aspects that you can share. There could be some kind of a sidecar, or there could be like a shared volume across these microservices. You are able to specify that. So in the sample, if you see here, for the front end, as well as for the RSS reader containers, there are two different containers with two different images. You are specifying the that for each of this in the pod, it has its own ports, so that using this specification, you might be able to then say the specific port number per microservice and still set it all up in the same pod. I want to go back to touching on this functionality of Kubernetes, which in our example, the hands-on, what you did was after creating the deployment, you actually set the service. This becomes one of the core functionality exposed by Kubernetes, the how you can correspond a microservice to a service and can be configured to be accessible in the cluster or from the outside. So in our case, if you remember, we actually set it in the so the load balancer was set up as part of that right? So that allowed, so when you're looking at the service that was set up, that shows what is the cluster IP, and that functionality is what Kubernetes is fundamentally providing for you. But as a developer, what you really need to know is that the name of the other Kubernetes services your app uses is really important. So, for example, again, we did not specify it using a YAML file for our simplistic example in the hands-on so far. We will look at it right after these slides. Is you have the API version, the kind is a service, and the name. This is the name of the service that you want to be paying attention to. For example, it could be in your app, when you are specifying a host name for a service, you want to use, let's say, what's the connection string for a DB, you would use that as the service name. So you want to be really careful as a developer to be using the correct service name for the corresponding service in your service YAML. Is that making sense? I'm going to pause again before continuing with more demo. Are people feeling like they're following along? Are you ready for more in-depth Kubernetes, or does it feel like, oh, maybe this is a good intro? Oh, there is a question here. Can we access the services using the load balancer IP? Yes, you can. That is the that is what is getting exposed as the external. Okay, I'll keep going. We have okay, we have 10 more minutes of allocated time for the hour and a half of the meetup. I want to pause after a couple more slides and take more questions, and then we'll do a gut check on where people are at. Another important feature is config maps. This corresponds to basically this corresponds to configuration files, whether it is a database config file or something like that. The kubectl command can create this config map for you as a developer. So as a developer, what you want to keep in mind is that the Kubernetes deployment file will specify which keys from the config map are available in your application. And you also want to really make sure that the config values that your app needs are made available through the config map in your deployment YAML. So you don't want to miss out specifying the appropriate configuration in your YAML file. Secrets is something we had already touched on earlier. kubectl again provides the ability, and you as a developer want to make sure that your app is using secrets as much as possible. The secret name will give you the keys, and the deployment YAML will show if that secret is available in your application or not. So here is sort of an overview of the level of Kubernetes abstractions that are provided. Today we looked at the pod and the service. When in this example, if you again go back to it, you are able to do the you can do the pod as well. We are able to see the pods and the services associated with it. There are a lot more Kubernetes provides in terms of the volume and the namespaces. There is also today we touched on deployment and what the create deployment provides. There's also many other things like the daemon set and the stateful set, replica set. These are all functionalities possible. I didn't want to combine everything into a very fast-paced tutorial without really giving people the level 0 exposure, since it looked like about 80% of you were saying this is sort of your very first exposure to Kubernetes. Happy to do follow-up sessions where we cover, so today we covered pod and service. We can cover the other aspects, as well as cover, something like stateful set. Most definitely, if there is interest, not as a developer, but also happy to cover as an administrator, which is where a majority of really Kubernetes functionality that you may hear comes from. And in my view, since this audience is really SDE skills, and most of you are developers, again, that's the survey response as well, that over 75% were developers. It did not make sense to cover the control plane functionality and so on. I'm happy to get into those as follow-on sessions if there is interest. But the most important thing or the terminology that you want to walk away with is the notion of a Kubernetes control plane. Really, this is the brain, if you will, of Kubernetes. That's where the Kubernetes master, remember I said it is really a master-slave sort of model in terms of how Kubernetes functions. So the Kubernetes master and all of the kubelet processes that govern how Kubernetes communicates, all of that is happening through the control plane. And the control plane maintains a record of all of the objects in the system. And that gives you visibility into when you use a Kubernetes API to create a deployment, you provide a new desired state for the system. You can do all of that. But really, again, going back to this audience, with your role as a developer, that's not what you would be doing. You are actively only worrying about your deployment YAML. This is the number one aspect of Kubernetes as a developer that you would be thinking and worrying about. Once you kind of really understand how the deployment YAML works and how that interacts with your Kubernetes and what are some of your responsibility as a developer, then you start to see how the rest of the functionality provided by Kubernetes is allowing you to do your job as a developer, wherein whether it is sharing of volumes or sharing of other resources, or leveraging like a stateful set, which may be a database or some other form. Those are all exposed through the deployment YAML. So this is really the bulk of what I wanted to cover today. We are 5 minutes away from the hour and a half of the planned session. I want to stop sharing now and again give time for more questions. And see if there are any other insights or takeaways that people would like to see in subsequent sessions as well. Other questions, folks? Can we access the service using the load balancer? Yeah, I think I already answered that. Is the session being recorded? Yes, it is. Can you brief about canary deployment? Yeah, hi Gayatri. Yeah, absolutely. So canary, so before talking about canary deployment, I think the key thing about deployments in general that I want to take a step back and answer is various deployment strategies and best practices that one can use, and I'm trying to answer this in a way that majority of the room can understand where I'm coming from. So Gayatri, can you let me know what your scenario is right now? Is your team currently using AB deployment or blue-green? What type of deployment practice are you using? Your question was
Hi Vidya, can you hear me?
Yeah.
So I am not aware about AB or the blue-green deployment scenarios that you're talking about. I hear this term canary deployment quite a bit in the place where I worked earlier. And what I vaguely understood from that was with every service being in multiple nodes and multiple clusters, so the deployment happens node by node. The same code base gets deployed in every node. Say we have 10 pods containing a particular service. So we'll have like 1 pod of the newer version and the 9 of the older version. And slowly the newer version increases and the older version decreases, just so that we also have the reliability of the service, is what I vaguely understood from the term and from all the conversations that we had. So I just wanted to understand if that is what it is, or is it something else that because this is something that I understood by myself.
Yeah, absolutely. So canary is a technique to reduce the deployment issues or errors that are experienced by the users. So what you want to be able to do is control the deployment such that when there is a new version, you don't want all the users to at once see all of the new functionality, and you want to control and slowly expose that. And by exposing the newer version in a very slowly controlled rolling update manner, that kind of technique is called a canary deployment technique. Rolling updates is provided by Kubernetes. That is definitely a really big, I would say, use case where rolling updates are possible, and the nodes, you can just have some of the nodes showing the new functionality.
Thank you, Vidya.
Yeah. Other questions? So there is something from Suresh. So just curious, before next session, can you outline what would be a prerequisite to get more involved in the workshop? Yes, absolutely. So I think I have a slightly different question before getting everyone into the next level. If you can answer, I'm putting it in the chat as well. Are you currently using Kubernetes? So the reason I ask this is because, just like any technology, right? Kubernetes by itself is really, really broad. I mean, there's just so much you can get into. Today, I wanted to really start off by telling you what are the basics as a developer again that you want to be aware of about Kubernetes. And then the next step after is really how do you set up Kubernetes? Is your hello world application where a sample cluster is being set up by you as as sort of the administrator and not just the developer. So one way to do this would be, you get into also Kubernetes administration. Another way to do this would be you continue to learn it as what a developer needs to know and get into more the deployment YAML. So you can also, you can all reach out to me. This is my email address, and let me know if you have a preference one way or the other. Of course, I'm on the Slack channel as well, because depending on that, the topics can be very, very different. So imagine, so as an example, you can be setting up Minikube in your desktop. You can be setting up a kubectl, the two main things that we use today in your laptop, but that is still not going to be enough. That will only be teaching you at a very basic level the configuration of Kubernetes in a single node scenario, which quite often is not a realistic case in a production setup. Production setup is always going to be, multi-node, multi-master, multi-worker kind of installation, right? If you want to just play with it all in one single node installation, Minikube is a great way to do it. We can absolutely have follow-ups based on that, or we can also have follow-ups, which I think is a recommended way to do it if we are all developers, is how do you, and I can talk to Bhavesh and see what kind of GCP cluster can be used, where you could be deploying and making edits to your deployment.yaml file and learn that, as well as maybe even before that learn how to create a Docker file, because I did see a couple of you mention that you're not familiar with Docker either. So the better next steps would be learning how to create a Docker file and then learning how to create deployment.yaml files. Other questions? Yeah, someone saying learning about Docker would be great. Yeah, sure. I'm happy to do a session that's about Docker, and that might be a place where you have to start if so many of you are absolutely new to Kubernetes. There is no point jumping into setting up a Kubernetes cluster if you haven't yet containerized your application. And yes, the slides will be available. I will post it on the meetup. Do you recommend a pathway to learn containers? Yeah, I can put a couple of sample tutorials. I will include that in the appendix. But definitely the first thing would be learning to do Docker files and learning to do simple containerization before getting into Kubernetes, if that's where people are at. Someone saying I'm not using Kubernetes, but working on microservices. If you're working on microservices, definitely the next thing I would recommend is containerization before getting into Kubernetes. Okay, other questions? Awesome. Thank you very much for joining. I'd love to hear your feedback on whether this covered what you're looking for. The slides will be posted in the meetup group. There was another question from Sudha. How do we monitor the heat of the pods running in Kubernetes? The health, yeah. So we can very much cover functionality like that about Kubernetes. You know, in this case, you can go into the dashboard yourself in the browser and look at it. But we can cover specifics like that in the subsequent sessions. Yeah, we are more than an hour and a half into the allotted time. Do let me know if there are other questions. We'll take it offline and plan the next session accordingly. Thank you. Bhavesh, anything else?
No. Thank you very much for the great session, Vidya.
Okay, thank you. I'm going to stop recording.
Yeah, thank you.